The Triassic period, lasting from approximately 250 to 201 million years ago, marks the beginning of the Mesozoic era, often called the Age of Reptiles. Following the Permian-Triassic extinction event, the most severe mass extinction in Earth's history, this period was a time of ecological recovery and transformation. Nearly 90% of life had been wiped out, leaving the planet barren and devoid of complex ecosystems. The Triassic served as a critical chapter in Earth's history, where life began to re-establish itself and new species emerged to fill the ecological voids left by the extinction. The significance of the Triassic period lies in its role as the era when dinosaurs first appeared. Originating from a group of reptiles called archosaurs, dinosaurs began to diversify during the late Triassic. Early species such as Eoraptor and Heterosaurus displayed traits that would later define the dinosaur lineage: bipedal locomotion, upright posture, and advanced skeletal structures. These adaptations allowed dinosaurs to thrive in a world undergoing rapid climatic and environmental changes. The Triassic also saw the emergence of other key groups, including early mammals, marine reptiles like ichthyosaurs, and flying reptiles such as pterosaurs. The end of the Triassic period was marked by another mass extinction event, the Triassic-Jurassic extinction, around 201 million years ago. Triggered by massive volcanic eruptions associated with the Central Atlantic magmatic province, this extinction drastically altered ecosystems by wiping out many competing reptilian groups. This created ecological opportunities for dinosaurs, allowing them to rise as the dominant terrestrial animals in the Jurassic period. The Triassic period was more than just the beginning of the dinosaur dynasty, it was a transformative era that shaped the course of life on Earth. It set the stage for the incredible diversity of species that would come to define the Mesozoic era. 2. Triassic climate and environment. The Triassic period was characterized by unique climatic and environmental conditions that significantly influenced the evolution of early life, including dinosaurs. During this period, Earth experienced warmer global temperatures compared to today, with no evidence of polar ice caps. These warmer conditions, combined with low atmospheric oxygen levels, created a challenging environment for many species. The climate was generally arid, with vast deserts dominating the interior regions of the supercontinent Pangaea. Seasonal monsoons affected areas closer to the equator, leading to sporadic wet and dry cycles that shaped the ecosystems of the time. Geographically, the world during the Triassic was dominated by Pangaea, a single massive landmass that stretched across much of the planet. This supercontinent was surrounded by a vast ocean known as Panthalassa, with a smaller inland sea called the Tethys Ocean. The vast size of Pangaea meant that much of its interior was far from coastal influences, resulting in dry, desert-like conditions. Mountain ranges and rift valleys also formed due to tectonic activity, creating a patchwork of habitats that would influence the distribution and evolution of species. The climate and environment of the Triassic played a crucial role in the evolution of early dinosaurs. These conditions favored species that were highly adaptable to harsh environments, leading to the emergence of traits such as efficient locomotion, upright postures, and advanced respiratory systems. Early dinosaurs like Eoraptor and Coelophysis were bipedal and agile, traits that allowed them to survive in arid landscapes and compete for limited resources. Herbivorous dinosaurs benefited from the expansion of gymnosperms, cycads, and ferns, which formed the primary vegetation of the period. The combination of arid climates, diverse habitats, and competitive pressures drove the rapid evolution and diversification of early dinosaurs. By adapting to the unique challenges of the Triassic environment, dinosaurs set the stage for their dominance in the Jurassic and Cretaceous periods. 3. The first dinosaurs. The story of dinosaurs begins with their ancient ancestors, the archosaurs, which emerged before the Triassic period. Archosaurs, meaning ruling reptiles, appeared during the late Permian and were a diverse group of reptiles that included ancestors of crocodiles, pterosaurs, and dinosaurs. These creatures exhibited key evolutionary traits such as upright postures, efficient lung structures, and relatively advanced locomotion. These adaptations gave archosaurs an edge in the arid and fluctuating climates of the early Triassic, allowing them to survive and thrive after the Permian-Triassic extinction event. During the Middle and Late Triassic period, a specific lineage of archosaurs began to evolve into what we now recognize as true dinosaurs. Fossil evidence shows that the earliest known dinosaurs such as Heterosaurus, Eoraptor, and Styracosaurus appeared around 230 million years ago. These early dinosaurs were relatively small compared to their later descendants, with many species measuring only a few meters in length. Despite their size, they displayed advanced traits that set them apart from other reptiles, including bipedal locomotion, lightweight skeletal structures, and efficient respiratory systems. The evolutionary success of dinosaurs can be attributed to their remarkable adaptability. Their upright posture allowed them to move more efficiently than sprawling reptiles, conserving energy and enabling faster movement. This made them effective predators and foragers in the competitive ecosystems of the Triassic. Early herbivorous dinosaurs like Plateosaurus evolved long necks and strong jaws, allowing them to exploit vegetation in diverse habitats, while predatory species such as Coelophysis honed their hunting skills with sharp teeth and keen senses. The gradual emergence of true dinosaurs during the Triassic was a product of evolutionary innovation and environmental opportunity. As climates shifted and ecosystems diversified, dinosaurs adapted to fill ecological niches left vacant by the extinction of other species. This adaptability laid the foundation for their dominance in the Jurassic and Cretaceous periods, marking the beginning of their 165 million year reign as the rulers of the Mesozoic era. For famous carnivorous dinosaurs of the Triassic. The Triassic period marked the rise of some of the earliest carnivorous dinosaurs, showcasing evolutionary traits that would later define theropods and other predatory groups. These early hunters were often small but agile, exploiting their environments with advanced adaptations for speed, hunting, and survival. Among the most notable carnivores of the Triassic were Coelophysis, Postosuchus, and Herrerasaurus, each representing a significant step in the evolution of carnivorous dinosaurs. Coelophysis, agile and adaptable. Coelophysis, one of the first and most well-known carnivorous dinosaurs, lived around 210 million years ago during the late Triassic. Measuring about 3 meters in length and weighing approximately 30 kilograms, it was a small, bipedal predator with a slender build. Fossil evidence suggests that Coelophysis was a swift and agile hunter, using its sharp teeth and clawed hands to catch small prey, including insects, lizards, and potentially even smaller members of its species. Trackways and fossilized remains found in what is now New Mexico indicate that Coelophysis may have exhibited pack behavior, a trait that would later be seen in more advanced theropods. Postosuchus, a powerful predator. Though technically not a true dinosaur, Postosuchus was a close relative within the Archosaur lineage and one of the largest predators of its time. Reaching lengths of up to 6 meters, it was a formidable predator with a massive skull, serrated teeth, and strong limbs. Postosuchus is often considered an apex predator of the Triassic, preying on early herbivorous dinosaurs and other reptiles. Its semi-upright posture and powerful bite foreshadowed the predatory traits of later theropods, bridging the gap between early archosaurs and true carnivorous dinosaurs. Herrerasaurus, a proto-theropod. Herrerasaurus, dating back to approximately 231 million years ago, is one of the earliest known theropod-like dinosaurs and a potential ancestor of the theropod lineage. This agile predator measured about 4 meters in length and featured sharp teeth, a flexible neck, and strong hind limbs. Herrerasaurus displayed characteristics that would later define theropods, including a bipedal stance and clawed hands for grasping prey. Its fossils discovered in Argentina highlight the rapid diversification of early dinosaurs in South America. These carnivorous dinosaurs and their relatives represent the evolutionary experiments of the Triassic. They laid the groundwork for the diverse and dominant predators that would follow in the Jurassic and Cretaceous periods. 5. Notable herbivorous dinosaurs of the Triassic. The Triassic period saw the emergence of some of the earliest herbivorous dinosaurs, paving the way for the massive plant eaters that would dominate later periods. These herbivores played a crucial role in shaping the ecosystems of their time, coexisting with predatory species and forming the base of the food chain. Among the most notable Triassic herbivores were Plateosaurus and Thechodontosaurus, each representing unique evolutionary adaptations to their environments. Plateosaurus, the dominant herbivore. Plateosaurus, often called the lizard of flat stones, is one of the best-known herbivorous dinosaurs of the late Triassic, living around 214 to 204 million years ago. This large, bipedal sauropodomorph could grow up to 10 meters in length and weigh over 4 tons. Its long neck allowed it to browse on a variety of vegetation, including cycads, ferns, and other gymnosperms, which were abundant during the Triassic. Plateosaurus is considered a precursor to the giant sauropods of the Jurassic, showcasing traits like a robust skeleton and a long tail for balance. One of Plateosaurus's most striking features was its versatility. Fossil evidence suggests it could switch between bipedal and quadrupedal locomotion, depending on its needs such as feeding or fleeing from predators. Its serrated teeth and powerful jaws were well suited for grinding tough plant material, while its large clawed hands could help manipulate vegetation. Fossilized remains of Plateosaurus have been discovered across Europe, indicating its widespread dominance in the region. Thecodontosaurus, a unique evolutionary path. Thecodontosaurus, known as the socket-toothed lizard, was a smaller herbivore that lived around 205 million years ago. Measuring about 2 meters in length, it was significantly smaller than Plateosaurus but equally important in understanding early herbivorous dinosaur evolution. This dinosaur's teeth suggest it had a more selective diet, feeding on soft vegetation like leaves and young plants. Its fossils, primarily found in what is now the United Kingdom, highlight its adaptation to a distinct environment compared to its larger counterparts. Unlike Plateosaurus, Thecodontosaurus likely maintained a bipedal stance most of the time, using its agility to navigate dense forests and escape predators. Its evolutionary path showcases the diversity of herbivorous dinosaurs during the Triassic, with different species adapting to unique ecological niches. Together, Plateosaurus and Thecodontosaurus exemplify the diversity and adaptability of early herbivorous dinosaurs. Their success in the Triassic period laid the groundwork for the massive plant-eating dinosaurs that would dominate the Jurassic and Cretaceous period. 6. Early marine life during the Triassic. While dinosaurs began their dominance on land during the Triassic period, the oceans were home to an equally fascinating group of creatures: marine reptiles. These reptiles, including ichthyosaurs and plesiosaurs, filled the ecological roles of top predators and shaped the dynamics of marine ecosystems. Though not dinosaurs themselves, marine reptiles share a common ancestry with them through the archosaur lineage, highlighting the evolutionary connections between land and sea life during this era. The role of marine reptiles, ichthyosaurs and plesiosaurs. Ichthyosaurs, meaning fish lizards, were some of the most successful marine reptiles of the Triassic. Evolving from land-dwelling reptiles, they fully adapted to life in the ocean. Their streamlined bodies, large eyes and powerful tails made them efficient swimmers, allowing them to hunt fast-moving prey such as fish and cephalopods. Some species, like Shanosaurus, could grow up to 15 meters long, making them formidable predators. Fossil evidence from Triassic strata indicates that ichthyosaurs gave live birth, an adaptation that freed them from returning to land to lay eggs, further cementing their dominance in marine environments. Plesiosaurs, another group of marine reptiles, emerged toward the end of the Triassic period. Unlike ichthyosaurs, plesiosaurs had long necks, small heads, and large flippers that allowed them to maneuver through coastal waters and shallow seas. These adaptations enabled them to ambush prey, such as small fish and crustaceans. Their unique body structure foreshadowed the diversity of marine reptiles that would thrive in the Jurassic and Cretaceous periods. Connection between land-dwelling dinosaurs and marine reptiles. Although marine reptiles and land-dwelling dinosaurs followed separate evolutionary paths, their shared ancestry lies with the early archosaurs of the late Permian and early Triassic. This connection highlights the adaptability of reptiles during this period, as they evolved to dominate both terrestrial and aquatic ecosystems. While marine reptiles never evolved into dinosaurs, their success in the oceans mirrors the rise of dinosaurs on land, showcasing the versatility of reptilian life in the Triassic. Marine reptiles like ichthyosaurs and plesiosaurs played a crucial role in the ecological balance of the Triassic oceans. Their emergence underscores the diverse evolutionary experiments of the time, setting the stage for the dramatic expansions of life in the Mesozoic era. 7. Impact of the Triassic extension event. The Triassic period ended approximately 201 million years ago with one of Earth's most significant mass extinction events. Known as the Triassic-Jurassic extinction event, it marked the transition between the Triassic and Jurassic periods, reshaping ecosystems and clearing the path for the dominance of dinosaurs in the Mesozoic era. This extinction wiped out nearly 50% of all species, including many reptiles, marine life, and early amphibians, paving the way for the evolutionary success of those that survived. Explanation of the mass extinction. The primary driver of the Triassic-Jurassic extinction event is believed to have been massive volcanic activity associated with the Central Atlantic Magmatic Province, CAMP. These eruptions released enormous amounts of carbon dioxide and sulfur dioxide into the atmosphere, leading to rapid global warming, ocean acidification, and widespread anoxia in marine environments. The atmospheric changes caused abrupt climate shifts, making it difficult for many species to adapt. The supercontinent Pangaea's fragmentation during this time further altered habitats, adding to the stress on ecosystems. Marine ecosystems suffered heavily with a significant loss of species like conodonts, ammonites, and marine reptiles. On land, large archosaur competitors of dinosaurs such as phytosaurs and early crocodile-like reptiles also faced extinction, the species that survived and evolved. Despite the widespread destruction, some groups managed to survive and thrive in the altered environment. Dinosaurs, which were relatively small and adaptable during the Triassic, were among the survivors. Their efficient respiratory systems, upright posture, and ecological versatility allowed them to withstand the challenges posed by the extinction. Early mammals, pterosaurs, and crocodilian ancestors also endured, along with marine reptiles such as ichthyosaurs and plesiosaurs, shaping the dominance of dinosaurs. The extinction event eliminated many of the dinosaurs' primary competitors, such as large pseudosuchians and other Triassic reptiles, leaving ecological niches vacant. With little competition and abundant resources, dinosaurs rapidly diversified and expanded during the Jurassic period, evolving into larger and more specialized forms. This event set the stage for their reign as the dominant terrestrial animals for the next 135 million years, defining the Mesozoic era. The Triassic-Jurassic extinction was both a catastrophe and a turning point in Earth's history. It highlighted the resilience of life and the ability of adaptable species, such as dinosaurs, to exploit opportunities arising from environmental upheaval.